extreme is those that maintain constant internal body temperature, which we might call core temperature. And on the other side of the scale are those that vary their body temperature in line with ambient temperature. Some animals maintain their normal homeostasis, but by aligning their body temperature with that of the environment. So basically, these ones generally achieve this by I want to make this lecture as simple as possible. So you follow it we are just sometimes we try to give you too much and we bother you and we bother ourselves at the end of the day. You know, so let's take it very simplify it a bit and make it simple. You know. So that's one thing with vets. You want to know everything, you want to know everything. At the end of the day, of course we're fantastic, but life should be made easy as much as possible. Okay. These ones, they either generate heat during cold condition. Conditions, or they dissipate heat. Or they lose heat. Can use the word dissipate or lose. They lose heat. They lose heat during hot conditions. So when they are exposed to cold conditions, they gain heat. When they are exposed to hot conditions, they lose heat. Then in between, some of them might just have they might just have what we call physical adaptations. Physical adaptations such as body insulation. Some of them have, force. Body may be insulated or not. Body insulation, because we are mixing the two now. Body insulation or not. So most animals that live in temperate regions, they will be insulated, right? Like, this part of the world where you have the thick skin, thick fur, and all of that. But the temperate zone, because of the high ultraviolet radiation, they have to have light skin and light hair. So it's going to be light. So the body is insulated here, but not insulated. Okay? And apart from having that thick skin and high pore density, they also have high adipose tissue deposited on the layers beneath the skin, so as to prevent heat loss. That is for those animals in the temperate region. But for those animals, in the temperate and then in the tropics, they have light skin, they don't have air, everything is exposed so that they can easily lose heat because the ultraviolet radiation hits on them so much. Then behavioral changes. Behavioral changes during different seasons in response to seasonal variations, such as the winter, the spring, the summer. So we'll talk about estivation, and so here we talk about something like hibernation, activation. So some of them can hide under the burrows or they can reduce activity. So all of this has to do with changes in activities, degrees of activities, changes in degree of activities. Some of them can conserve energy, they can also active entities. So then we also talk about okay, a lot of this happens in behavioral changes, so we'll talk about. Then in these ones, they mainly exhibit behavioral changes. Such as staying under the sun, cuddling together to keep warm, and sometimes they also respiratory changes. They might also undergo this hibernation and distillation as the case may be. So this we talk about when they do any of this, when they generate heat, we talk about thermogenesis. They generate heat, produce heat, and they can do that by, they can generate heat by muscle contraction, they can do that by exercise, they can also do that by metabolic heat, cell metabolism. You can go we always leave it at metabolic heat, especially with the adipose tissues. Special reference to brown fats in young adipose. And then they can also, for these ones, they can do that by so this muscle contraction produces what we call shivering. Which is going to be called shivering thermogenesis. Then exercise and metabolic is going to be called non-shivering thermogenesis. And those that dissipate heat to the environment, dissipate heat during hot weather will be by sweating. Cold conditions, you also may have what we call piloerection. You know, when cold moves over the surface of the body, when cold air moves over the surface of the body, it tends to cool the body. So during cold generation, cold, you don't want the air to move. You want something to act as a brake, to stop the air from moving, so the air will stand there erect. So that is called piloerection. which is due to contraction of the piloerector muscles that control the air follicles. So this is due to what? Contraction of the piloerector muscles. Okay, so this keeps the head erect and acts as a brake on the convection air current, which will tend to cool the body further, and you don't want that to happen. I'm sure you would have had those pimples sometimes, you experience that, when it is too cold. So those pimples are as a result of the contraction of the air follicles, and the pumps come up because of that. So you don't have that when they're in hot weather, right? You have it cold. So it's a thermoregulatory response to keep the body warm and prevent the air from cooling the body. So this and this. So when there is which means here, please look up. Which means here, there must be a sensor. There must be a sensor that will detect what is happening, either the effect of the cold or the effect of the. So at the center of the whole thing is the hypothalamus. If I was a tech guru, I would have made so much money on my YouTube by now. Right? Yes. I want to know how to press my computers. I really don't know how to type. When it comes to editing, he's looking at me as if he wants to help me. Can I give you? I mean, that's kind of weird, right? You want to help me? So it's you need to turn your gift to money. I was just driving the truck. I was like, ooh. Trekking, all of that. I said, money answers every question. Money solves every problem. If you remove money from the equation of our lives, let's get to the book of the head. Money out of it, life becomes so challenging. I was like, oh, let's try. I had my narrative. So that's the way it is. So, what I'm trying to say is that in a couple of these lectures that if one can put them together, I'm sure you have solve some problems. You have some other people. So, now, which means something has to detect that change. If there is either cold weather or cold condition or hot condition, it will affect the blood first, right? The blood temperature will change, and something in the body has to act as the sensor that will detect that and then begin to respond. So the hypothalamus is the sensor. It senses the cold condition and senses the hot condition. By what? By detecting the temperature of the blood. So it is going to have what? Osmoreceptors or thermoreceptors? It is going to have thermoreceptors. So there are thermoreceptors on the thermoreceptors on the hypothalamus. So when they sense cold, so I'm going to put this guy here. We want to gain heat here, right? When the body is exposed to cold, heat has to be generated, right? So the posterior hypothalamus, responds to changes in cold temperature. And when it responds, it's going to do what? Generate heat. So it is going to be, we are going to describe it as what? Thermolytic or thermogenic. How do we describe the posterior hypothalamus by virtue of the fact that it manifests this? Is it going to be thermolytic or thermogenic? So it's going to be thermogenic. There are things you don't need to cram. All you just is be part of the lecture and you are good. Thermogenic. So, is it clicking now? Good. Then the one that responds to heat is the anterior hypothalamus. And when the animal is exposed to hot weather, it's supposed to lose heat, right? So in order to keep the inner core temperature constant, so it's going to mobilize mechanisms that will dissipate the heat. So it's going to be described as a thermolytic. So it initiates, this is thermolytic, and then heat is lost. Okay? So if all of this happen in the animal, we are going to be describing this animal as endothermic. Endothermic. Animals that mobilize these mechanisms to maintain inner core body temperature constant, thereby keeping the normal cell function, is called endothermic. So they generate heat and keep it inside. You can also call them homeothermic. Homeothermic animals. And examples will be mammals and birds. They are endothermic and homeothermic. So, but the animals that employ this mechanism, their body temperature varies with that of the environment. They are called ectothermic, because the temperature is this ecto means what? Outside. The temperature is regulated by the outside temperature and not what is inside. So because of the fact that, so if they move to a particular zone, they align to that environmental temperature. If they find themselves, their body temperatures align to that. If they find themselves in other zones, that's why you talk about bird migration. Birds migrating from one zone to another, talk about. So the reptiles and the snakes and all of that, their temperature changes with that of the environment. So they are going to be called poikilothermic. Poikilothermic or ectothermic, they are the same thing. Ectothermic in the sense that the temperature is regulated from the outside. Poikilothermic in the sense that it changes, just like we say poikilocytosis in red blood cells, changes in shape, right? So it varies. So now we have looked at these two groups of animals. So this is what the endothermic or homeothermic animals employ to regulate their body temperature. And this is what, so examples here will be lizards, reptiles generally, and then some lower terrestrial animals. Then for the marine birds, so in between, for the marine animals, in between the two, we have what you call the thermoconformers and thermotolerant. So all of these from here, they can actually conform to their body temperature. Go to the marine birds, thermoconformers. So they conform to the temperature of the environment. But the unique thing about the aquatic animals, they are found deep down the sea. So they have, their body can produce what we call thermotolerant crystals. So their body temperature cannot change. So because of that, they have what we call cryoprotectants. Aquatic animals that live in the ice sea, they have what we call cryoprotectants. cryoprotectants. So these ones, they are basically ice crystals produced by these animals which prevent a change in the cell wall of their membranes. So with that, environmental temperature cannot affect the temperature of the cell inside their cells, because their cells produce what we call cryoprotectants. Cryoprotectants are substances which are usually glycolipids, produced by certain marine animals that wall off their cells from being affected by the prevailing cold temperature deep down the sea. Does that make sense? Ideally, what will happen deep down the sea is that they will freeze, right? They will freeze, right? So cryoprotectants are antifreeze agents. So they are antifreeze agents. Okay. So, in between, what cuts across all of this, especially here, because we are more concerned with the mammals and the avians. So, another mechanism, we have looked at what? Thermoregulation. We have looked at thermogenesis. We have looked at physical conditions, and of course, thermogenesis is described as shivering thermogenesis and non-shivering thermogenesis. And we have also looked at sweating as a heat loss. So, the next one is vascular reaction. How does the circulatory system and the skin help to regulate body temperature? So, we are going to now, that's the last point before we consider fever, and my lecture will be done. So the next one, number 4, is what? Vascular reaction. Vascular, let's say circulatory responses. Why don't we use that word? Circulatory responses to circulatory. Circulatory mechanism of what? Mechanism of what? Circulatory mechanism of what? Sinks. Circulatory mechanism of thermoregulation. We have just said thermogenesis, physical adaptation, sweating, and then we are looking at what? Circulatory mechanism. One thing is that blood is a good conductor of heat. Blood has a high specific heat capacity. What does that mean? It can store heat significantly. It can retain heat. And again, tissues are poor conductors of heat. So you don't rely on tissue to tissue contact or cell to cell to contact to transfer heat in the body. No. Heat is transferred in the body through what? Blood. And where is this heat coming from? The heat is coming from metabolic heat, ultraviolet radiation, and all of that, and exercise. So all of these impacts on the blood, and the blood maintains a certain temperature, which aligns with that of the body. Now, if the temperature of the blood increases beyond the normal limits, there is going to be a circulatory response that will readjust the body temperature to normal. And that circulatory is what? Vasoconstriction or vasodilation of the blood vessels supplying the organs, including the skin. But because we don't want to lose the heat into the body, if the body is already hot, we have to lose it outside, right? So the skin is very important. And the skin circulation is called what? Blood circulation to the skin is called what? Cutaneous circulation. Cutaneous circulation. So cutaneous circulation is very important here. Cutaneous circulation. So, during heat, do you expect in hot weather we want to lose heat to the outside? Do you expect blood to flow in large amounts to the skin or less amount? In less large. So what are we saying? We want more blood to take away heat, so through the skin. So do you want less blood to go to the skin or much blood to the skin? More blood to the skin. So we are going to have what? To support that increased flow, are we going to have vasodilation or vasoconstriction?
No.
Good. So we are going to partition it now. Cold, hot. So during hot weather, there's going to be what? Cutaneous vasodilation, and then cutaneous vasoconstriction. So that here, when blood has gotten to the skin in large, so that's going to be what? Increased blood flow, decreased blood flow. So when there is a decreased blood flow to the outside, it goes inside, right? It goes to the visceral organs. So there's going to be visceral organ vasodilation and cutaneous vasoconstriction. So in the cold, there's going to be cutaneous vasoconstriction and visceral vasodilation. With that, there's going to be heat retention. Does that make sense? And maintenance of the inner body core temperature. With this, there's going to be vasodilation and increased blood flow to the skin, decreased visceral organ flow, decreased visceral blood flow, which is going to lead to, so because of this increased blood flow to the skin, there's going to be vaporization. The heat will condense and the heat will, the heat interface with the outside will lead to evaporation of vapor. So vaporization and condensation. Vaporization, condensation, and then sweating. Sweat glands will be stimulated and be sweating. Increase the sweating. All right. Now let me introduce the concept of anastomosis. That is the skin, and then the blood that goes to the skin comes this way, and there is a shunt. There is a shunt that connects. This is the shunt. This is the vein, and this is the capillary, which belongs to the arterial system. So we call it what? Arterial venous shunt. And it is what? An anastomosis. Have you done that in anatomy? Is that right? Anastomosis. It's not correct. So this shunt diverts blood. As blood goes to the skin to lose heat, that is what is desired. So to support maximum blood flow, and we say that during hot weather, we want sweating, we want more blood to go to the skin. So do you expect this to close or open? If this closes, more blood will go to the skin. This is in the deep side of the skin. This is on the surface of the skin. So if this, you can imagine a situation whereby this is wide open, this blood will go away from here and flush away from the skin. So not enough blood will go to the skin. So during hot weather, we want more blood to go to the skin. So this is going to do what? Close. So the arterial venous shunt will do what? Close. We are talking about the and as the arteriovenous shunt of the skin. There are also arteriovenous shunt of other tissues and organs. We're talking about the skin. So with this, if this is closed, more blood can go to the surface, right? And dissipate the heat. But in cold weather, if more blood should be allowed to go to the skin, we lose more heat and leave the body at a negative temperature value. So we want this to open very wide. So it's going to open and open so that by the time blood wants to go to, everything will divert and go to the inner body. Okay? So cold water, it does what? The arteriovenous shunt opens. In hot weather, the arteriovenous shunt closes. So I want you to know that I'm bringing this is A, 4A, and 4B is the arteriovenous shunt mechanism. Does that make sense? So cutaneous circulation, we are dealing with ordinary dilation and constriction of these vessels. And then another factor that can play on it is what? The opening and closing of the arteriovenous shunt. Because the skin, cutaneous circulation is not just about this, it also includes this. So the skin has good arteriovenous shunt, which we will discuss. So that has been discussed. So now we are looking at those two extremes of arteriovenous shunt and cutaneous vessel constriction and cutaneous vessel dilation. So that has been discussed. So the role of circulatory role in controlling thermoregulation. Then the last thing is, there are three more concepts that are remaining, and we are done with thermoregulation. One is heat transfer. Two will be the heat transfer, including the principles of heat transfer, or the principles how heat transfer mechanism comes into the principle of thermoregulation. Next one is fever, and finally frostbite. So we take these three concepts and we go for a break, and then we are done. What can be exposed to cold weather or be exposed to hot weather? But even without that, naturally, we are not in a closet, right? We are naturally exposed to the outside. And these outside are objects. And objects are always in contact with us, directly or indirectly. And heat is always exchanged between one body and another. That is part of the ecosystem where we are being. So, how then do animals get exposed to heat? Is it by warming something, by making up a fireball somewhere? No. Is it by carrying the animal to a well, an enclosure where you have ACs and fans and all of that? No. It is by the natural mechanisms of heat transfer. And there are four mechanisms. One, conduction. Convection, evaporation, and radiation. These are the heat transfer mechanisms. So we exist in an environment where heat can be exchanged. Where heat can be exchanged between one body and the other, or even the environment, between the animal and other objects. So heat, animals can gain heat, lose heat, transfer by any of these mechanisms. So by conduction, an animal may be lying in contact with, may be directly in contact with either a cold object or a hot object. And by that, it can exchange heat. Heat can be transferred from one body to another. Convection is by the free flow of air, right? The same way with the circulation of blood. The movement of blood in circulation is by convection current. Likewise, with the effect of air on our body and that of the animal too can affect the heat transfer. That's why you put on AC or you put on the fan when you feel hot, so as to increase the convection flow of air over your body. Then again with conduction, the same goes with convection. When you are cold, what do? You cover yourself with a duvet, right? You don't want more air to flow over you by convection current. Or maybe you talk in your body and all of that. You are reducing the surface area. You reduce the surface area of your body. That's exactly what happens when animals huddle to. They huddle to. First of all, they exchange heat among themselves, and by that enclosure or talking in themselves, they have reduced their body, the surface area exposed to convection current of the air. So the body will not heat as much. Again, radiation. Radiation is by what? Exchange of heat by ultraviolet rays. So when the animal is outside there, the rays from the sun can also hit on the body. Again, the heat emitted from the animal can also radiate outside of the body. Again, when the sun heats up the soil, the ground, in the daytime, in the night time, they tend to emit the heat, right? So the animals, when they lie down on the ground, they also pick this heat. That's what you call land sea breeze. Those of us that don't see that in physics. During the daytime, the sea picks up the light, picks up the heat from the sun. During the night time, the environment is quiet, and then they have to. So all of these constitute different forms of heat transfer. What about evaporation as well? We talked about sweating. So when an object is heated up against another interface, the heat can be dissipated through evaporation. That is the formation of vapor, and then it condenses as water, and then they can be. So the animal, by nature of being on earth, likewise us, we are in contact with several objects by which heat can be transferred by any of these mechanisms. So that is all about heat transfer. So in other words, animals are subject to what? They are subject to gaining or losing heat by any of these mechanisms from the environment. And when they do, their body temperature may be affected. And for endothermic animals, they have to employ physiologic mechanisms that will keep it constant. And those mechanisms are what we have mapped out. For ectothermic animals, they just have to do what? Employ the normal behavior that will help them, which means they either have to come out to the sun, or when they are cold, or they run away from the sun. They go under the shade when they are hot. So, or when they find the environment unconducive. So all they need to do is to adopt a behavior that will help them align, that will help their inner body temperature to align with outside. Okay. Now fever. What is fever? Fever can also be referred to as pyrexia. You can also call it pyrexia or hyperthermia. That is abnormal increase in body temperature, especially for what? Endothermic animals, right? So why does it happen? Fever is a protective mechanism, usually in response to the presence of foreign bodies in the body. It is a protective mechanism in response to the invasion of the body by what? By a foreign organism. So it is what? It is a first line evidence of what? An existing infection in the body. So it is good that we have fever. Fever is good. In a transient form, yes. In the sense that fever is mobilized to challenge the invading organism. It's a physiologic defensive mechanism to the invasion of the body by an organism, foreign body. However, if the protective effect of fever is not successful, then the organism thrives. Then the fever becomes continuous. Otherwise, fever is supposed to be what? Transient. When the organism is conquered, then what has happened that led to the development of fever will be reversed. But if the body cannot, if the fever is not sufficient enough to take care of the organism, it becomes progressive. So let us now explain how it works. When a foreign organism invades the body, the following fever develops by the following cascade. So I want to put it 1, 2, 3, 4. Fever, so now number 1, invasion of the body by a foreign agent or organism. But before we say that, what is the central role of the hypothalamus? You do what? Excellent. So the role of the hypothalamus is to detect a change in body temperature and initiate a control mechanism that will bring it back. So which means, like a thermostat in our iron or whatever things we use, when the temperature is above a certain state, it cuts off. When it gets to a point, it clicks again. That's exactly what it happened. So, in other words, the regulatory control of the hypothalamus is as far as it can detect a change and correct it, which means there is a limit to that. The hypothalamus recognizes a normal limit, and that normal limit is called the normal set point. The normal set point temperature of the body, what you call the set point. The temperature set point of the hypothalamus, which is normal. But if the body is challenged, certain chemicals will be produced, and when those chemicals flow to the hypothalamus, it changes the set point of the hypothalamus, and the hypothalamus will increase its activity and align with a new temperature, and that new temperature to which it has now aligned will become the normal for the hypothalamus. And whatever the hypothalamus says in terms of temperature, that is what the entire body cells assumes as normal. So whatever temperature the hypothalamus assumes, every other cell will work hard to get that new set point. Does that make sense? Good. So number 1, so having understood that foundation, that principle. So number 1 is what? Invasion of the body by a foreign organism. 2, production of pyrogens. So these foreign organisms will start producing proteins called what? Pyrogens. Not just the foreign organisms, but the foreign organisms will also stimulate the body cells to start producing what we call cytokines and interleukins, which of course you have done in immunology as what? As immunologic proteins or inflammatory proteins or inflammatory. So you have cytokines, you have interleukins, you have prostaglandins. These are now being produced as a result of what? The pyrogens. Now, all these inflammatory mediators will be high in blood, right? And then as the blood carries all these molecules, prostaglandins, interleukins, cytokines, by the time they get to the hypothalamus, they change the set point of the hypothalamus, usually higher. So there's going to be a new set point, temperature set point. And that's when you start having fever. So if the normal body temperature is 37.1 degrees centigrade, by the time pyrogens invade the body and all of that, it can be parasites, it can be anything. It can go to 37.8 or 38 or whatever. So that is now the new set point created by hyperactivity of the hypothalamus and all of that happening in the brain. So the body now has a new set point. So the body is now, and then the body cells will start saying, oh, let me see. So which means we are now at a lower range, right? Our temperature is at a lower range. The set point is not the fever. It is the response of the cells to the new set point that will produce the heat. So the set point has now moved from 37.1 to 37.8 or even 38, which is higher than this. So originally, the body cells are seeing this as normal. But with these pyrogens invading the hypothalamus, this is now what the normal. But they are still at this level. So what will they do? They will do what? They will work harder to do what? By doing what? Metabolism and more heat to be produced. So the production of that heat is cortisol. So as they work hard to produce more heat, to align with their master, because that is the master. The hypothalamus is the master. So to agree with their master, they now keep working hard because they say no. They feel cold basically. The cells are like there, so they have to produce more heat. It is that production of the heat that is within the body that now generates more heat. That is why you start sweating. Suddenly, the heat of the body becomes so uncomfortable for the microorganisms and they start dying. So the more the microorganisms start dying, the less the pyrogens. Does that make sense? So once the pyrogens starts reducing, the process is what? Reversed. But in most cases, it may not be as that sweet. The pyrogens are still fighting, and sometimes the load is too much. The bacterial load, the parasitic load, or whatever is too much that we need at this point, we need some to practical. So otherwise, fever is intended, is a first line physiologic response to get rid of the disease. But most times it doesn't succeed. However, so now when the body had cleared off, it might clear off or it might just reduce. When it tries to reduce the organisms, the pyrogens reduce. Suddenly, the hypothalamus again comes back to this. Meanwhile, the body has already produced so much heat, and then you sweat. And when it turns back to this, the body becomes again a little bit cool. So that is why in fever, sometimes when you have fever, before you know it, you are covering yourself. In the next 30 minutes, you are removing everything. So that fine. It keeps on fluctuating. So that is exactly what happens. So the last but not the least will be the frostbite. And then we conclude. So frostbite is the direct opposite of fever. So while fever is hyperthermia, frostbite is what? Hypothermia. And why would an animal experience hypothermia? When it is exposed to excessively extreme cold weather conditions. So if this is not controlled, there is going to be ice crystal formation in the tissues. And when this ice crystal formation is formed in the tissues, then it shuts down the cells. It shuts down the enzymes of the cell. Remember, enzymes work at a specific temperature. So when this is either too high, as in fever, or too low, as in frostbite, it's going to affect cell function. And in case of frostbite, none of these two is good in terms of extreme. But frostbite might develop a bit, and all you need is to work on some exercise the animal. That's fine. So that's why most of these animals should not, especially indoor pets, they should not just be kept indoor completely. Sometimes it would be nice to expose them to a bit of warmth. So that brings us to the end of thermoregulation by virtue of the review and all of that. So when we come back from our break, we will quickly